proof itself, numbers, angles, use the numbers. It's just easier to write. If it doesn't give you numbers, you can't just make up numbers, okay? Because then you're just making stuff up. So you can't assume. So AB is parallel to DC. There's your given. So these two guys are parallel, which means we follow the transversal, 1 and 4. Okay. Angle 1, congruent, angle 4. Two parallel lines cut by a transversal.
Wait, is it okay if we did do lettering?
Yeah, that's fine. Alternate interior angles are congruent. Okay. All I'm saying is that if it has numbers, it just makes your life easier. That's all. But you can't just write in numbers if they're not there. Do the next one. You've got AD is parallel BC. So these two guys are parallel. So you follow your transversal. You got 3 and 2. Same reason. Parallel lines cut by a transversal. Alternate interior. Angles are congruent.
Wait, Mr. Murphy,
Yes, ma'am.
why did you tell us to change it to
Because if I had it as congruent, it won't work. It winds up being an angle side to side. It doesn't work. It was a typo on my fault. And you probably noticed that I just wanted you guys to practice a lot of parallel proofs yesterday because that's the trickiest one. So now you've got two angles. Oh, I forgot to mark my diagram. I know. Two angles. What am I missing?
The middle is AC.
Because it is. Very good. Hey, if you wrote CA and CA, is that wrong?
No.
Nope.
It's just backwards, but the same thing.
So now why are your triangles congruent?
Say it.
C.
How do you prove
C,
triangles?
C, C.
Is that how you prove triangles congruent? Is that how you prove triangles congruent?
It's the lettering.
Lettering, alphabet soup. Your triangles, A, B, C, and C, D, A. A, B, C, and C, D, A. Notice I'm following my tick marks by angle, side, angle. Which triangles can only be proved by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. After you have triangles that are congruent, that is when you're able to say,
C, P, C, C, C.
correct. That's when you can say that these two
C.
can you use it twice?
Yeah.
Absolutely. Absolutely. Does not matter. Okay? Not terrible, is it?
No. Not at all.
Good. Let's talk about equilateral and isosceles. Equilateral and isosceles triangles. I've got a little bit of notes on this, a little bit more algebra today. We will not do any proofs whatsoever dealing with isosceles or equilateral. The only thing we're going to be looking at is a couple of definitions, as well as, excuse me, some very basic algebra stuff dealing within the triangles. Now, when we talk about these things within triangles, it's not bad because you're looking at, it's some of the interior angles is how much and things like that, following tick marks. Back in the beginning of this chapter, we talked about different types of triangles. One of the types of triangles that we talked about was an isosceles. We all know that an isosceles triangle has one pair of congruent sides. It has one set of congruent sides, and then that the angle that is in between those two congruent sides is called the vertex angle. Now, what's different with isosceles triangles is that there are two ways to write them out, depending upon the information that you're given. And it's actually very, very easy to distinguish between the types. Before I get there, when you have your two legs that are congruent, the two sides, what do you know about the base angles then? They're the same, very good. Now, when I'm talking about base angles, I'm talking about, see how the tick marks are here and here? Well, they are looking at the base angles. Okay? So isosceles triangles tell you if you've got legs congruent, the two base angles are congruent. The ones that are looking at it. Or vice versa. Sure. Or if you have those things, those angles are looking at the legs. It's looking at these.
Feet.
Yes. They're feet that are crisscrossed inward, like you've got, where's that, pigeon toe?
And the bottom side is the shoe.
Sure. But does it always have to be on the bottom? Could it be sideways?
Wait, wouldn't that mean you're stretching?
Only on a leap year.
You're not stretching.
Okay. Two ways you can write out isosceles triangles. Excuse me. I'll give you a second. I want to get ahead of you. Yes, ma'am. Yes. Called the vertex angle. If you squint really, really hard, it shows up just fine.
Oh.
So we have the ways that you are able to write out when you have information about an isosceles triangle. This is where the language of writing these things comes into play. For example, like I said, there's going to be two different ways to label and draw an isosceles triangle. If I say that triangle ABC is isosceles versus triangle XYZ is isosceles with Z as vertex angle. I should put an angle symbol here. What's the difference between those two statements? Yes, sir.
The second one actually gives you more detail.
Okay. Now, the second one gives you more detail, so that means that if I draw that picture, it's a little bit easier, correct? If I draw this one, if I say X, Y, and Z, Z is the vertex angle. Z is the angle that is in between the two sets of congruent sides, which means what would be the two congruent sides? Which ones? XZ and YZ. Now, you can label triangles a bunch of different ways. You can draw them a bunch of different ways. What happens is, when it tells you specifically which letter of the three is the vertex angle, that's the one that's always going to be between the two sets of sides. Like you said, Mr. Leon, it's a little bit more specific. Whereas the other one is more generalized. This one is a more general way of writing it. It doesn't tell you specifically which one is going to be the vertex, which means you have to make an assumption. Yes, you're going to have to make an angle side-side out of yourself for a second. But this angle side-side assumption is pretty easy to deal with. What's the middle letter?
S. B.
Wait, what? I thought you were talking about AS.
What's the middle letter of A, B, and C? B. So if it doesn't tell you, specifically which one's the vertex angle,
Just mark whatever.
no, always use the second letter.
Oh. Yeah.
That's it. This, if it doesn't tell you, it's assumed that the middle letter is. Okay? If it doesn't say specifically, it means that the middle letter is the vertex angle, and you get that. Okay? That's when you, this is the one time I'm going to allow you to make an assumption. because it's more of a generalized practice for isosceles triangles. Okay, does that make sense? It's very easy. Don't get me wrong. It's pretty easy to tell the difference between the two. One tells you what it is, the other one doesn't. And if it doesn't tell you, it's always the middle letter. Okay. You buying it or no? You guys. All right. Let's do an example here. Well, equilateral. Will the way that the lettering goes for equilateral triangles have any problem at all? No. Because what do we know about equilateral? They're all the same. If all the angles are the same, we also know that all the sides are the same. That means all of their angles are the same. And if all the angles are the same, they all are going to have to measure 60. So that's how this works. So what if he does?
There's someone at the door. 2 people at the door, actually.
Thanks, sir. So, again, it goes with the idea that if they're equilateral, that means that all the sides are the same, which means that all the angles are the same. So if all the angles are the same, all the sides are the same, and if all the sides are the same, all the angles are the same. It's kind of a Pete, repeat, run the boat, Pete fell out, who was left? Pete, repeat, run the boat, Pete fell out, who was left? Pete, repeat, run the boat, Pete fell out, who was left?
Neither.
Say it again.
Yet again. Okay? It is very simplistic. Okay? So, same deal, we've done that. Hey, what does this mean?
The outside.
The perimeter, yeah. How do you find the perimeter of an object?
Add up on the side.
You add up all the sides. So if that's an equilateral triangle and one side is 15, what do all the sides have to equal?
15.
So what would be the perimeter?
15.
No,
No,
30.
45.
30.
I was just looking at 2. Wow.
So maybe you might want to remember this little bit of a hint for Friday. You need a calculator, ladies and gentlemen. You have to have one here when you get here, okay?
It's like angles outside.
He said I'm not you.
No, I said I'm not you.
He said you.
What? I didn't say that. Yeah, exactly.
I specifically heard Mr. Murphy's English.
Let me give you guys.
What?
Oh, while I'm passing this out, do me a favor, double check the website. I think they finally got it figured out.
Yeah, I did it again and I just had to clear it again.
I think it's working now. They've been working on it all morning. They think they finally found a fix. So take a couple minutes while I pass this stuff out. I want you guys to check the website, make sure example of what we're going to be able to do when you have isosceles and equilateral triangles kind of melted together. So what you're trying to do here is solve for x, which means we have to figure out how we set it up. The triangle on the left-hand side here is of what type? Equilateral, good.
Oh, yeah.
So if I'm going to say that it's equilateral, I'm going to go ahead and make my tick marks. Guys, it is so important to mark your diagrams. All 3 of those sides are the same. You okay with that?
Yeah. So that means
Now-
this side's 60. Am I right or am I wrong?
What's 60?
Don't they equal 60? All sides?
Sides don't.
Oh,
Angles
angles.
do. Angles do.
Not the same thing. Let's go.
Now the triangle on the right then, the triangle over here is now what type? It's isosceles. It's an isosceles triangle. They're giving you the base angles. the base angles are pointing at the sides that are congruent, which means if this side has a single tick mark, this side needs a
Tick mark.
single tick mark. Therefore, what do you know about 6x minus 5 and x plus 5? Bless you.
Thank you.
They're equal. Bless you.
Thank you. Thank
So
you.
now you set it up.
Oh, I did.
And that's how this stuff is going to work. It's a matter of working through a diagram to figure out how you set it up. It's a matter of following your tick marks, matching it up. Did it work? Did you read both mark there? And you go through that way. Now you have a two-step algebra problem. Those are quick. Two-step algebra, you're going to add 5, you're going to subtract 1x. Dun, dun, dun. 5x. 10. X is? Okay. And it all stems from being able to follow tick marks and use the properties of equilateral and isosceles. Okay. Proud of your grandson?
Oh my God,
Yes.
this is so- oh, this one is so easy. This one's real nice.
You don't have to like actually find it.
No, but you know what? We could find the angles.
No.
Here, watch. If this is 60, this is 60, that's 60. Do you agree?
Mm-hmm.
What is this form? Yeah, 180. So what's 60 plus what is 180? 120. Now, how many degrees are in a triangle? What's 120 minus, or is 180 minus 120? So you have 60 degrees left for these two angles. What are they both?
30.
There you go. So yes, you can use the angles to get you there. That's the kind of process that we'll get to, okay? Using the interior angles to solve stuff through. This one didn't ask us to do it, but believe it or not, there will be ones that will. I think on the next page, I want to look at number 7. Number 7, it asks us to solve for angles x, y, and z. You have two triangles here, both of which are equilateral. We know that they're equilateral because you have the tick marks on the sides. Everybody see that okay?
Mm-hmm.
So, did I say equilateral? I meant isosceles, thank you. Yeah, they're sorry. They're isosceles. Now, one of the two triangles, you have more information than the other. You have more information on the triangle, bless you, on the triangle on the left. Because the triangle on the left, you know, has a vertex angle that measures how much? 51. How many degrees are in a triangle? 180. So in order to figure out the base angles, I take the 180, subtract 51, I get 129. So these two angles here and here have to add up to equal 129, and they have to be the same angle. Which means, what do I do to the 129 to figure out x?
Divided by 2.
Very good. I cut this guy in half, and I'm going to get 64.5. Is it okay that you get a decimal? Absolutely. It can happen, guys. So that means that angle x equals how much? 64.5. Which means the angle down here is also 64.5. Now, on that bottom angle, it's a right angle. Two angles that form a right angle are called what? Well, they will be acute angles, very good, but what's complementary? Good. Complementary angles have to add up to equal how much? 90. So 64.5 plus what is 90? How about use a calculator?
25.5.
So this here becomes 25.5. And again, notice, it's another, dun dun dun, it's another isosceles triangle. So if that angle on the bottom is 25.5, what's angle y? 25.5. How many degrees are in the triangle then? 180. So I have 180 degrees. I have 25, 5, and 25, 5, which means angle Z is. And all I'm doing is using the properties of the sum of the interior angles. The three angles within a triangle will always add up to equal 180. Okay? And just walking through it. All right? You're just walking through it. Not terrible, is it? Follow your tick marks and work it through. What's that? Z was 129. The reason, again, remember, you've got base angles that are the same. They're both 25, 5. If I add that together, I get 51. In a triangle, is 180 degrees total, so I just subtract 51 from 180, and I got 129. Hey, what's missing on this picture? A picture. Number 11 here, I want you guys to take a minute and solve it, and we'll check it. This is the kind of thing that you're going to have to be able to do. You have to be able to, so we have an isosceles triangle, DEF. Does it tell you specifically
No.
where the vertex angle is? So which means we have to make it at where?
Middle number.
Middle number. Middle letter, so it's going to be,
You know, just keep going.
actually I'll give you that. That is a number.
Oh my
What
god.
is it?
It is.
Yeah.
It's an.
Imaginary number.
It's not imaginary.
It
It's
doesn't
E,
make
E
sense.
is the letter E, it's log base E, it's, never mind. Anyway, so
It's like an
E
imaginary
has to
friend.
be your vertex because it's the second letter, because it wasn't told to you any other way. So you use that. Fill in the blanks. X plus 7, 3x minus 1, and 2x plus 5. Which means if I need to figure out the measurement of each side, which two do I set equal to each other? Yeah, the ones with the tick marks. That's the whole idea of drawing it out. The x plus 7 and 2x plus 5. That's why we draw pictures. This is a very, very fast algebra problem. Moving them around, you get x is 2. Good. So what's also nice about being isosceles, let's say define the measure of the sides. So that means you have to substitute back in, and this is really easy. What's 2 plus 7? What's 2 times 2?
4.
4 plus 5 is?
9.
9.
What's 3 times 2?
5. I meant the 8 is 5.
6 minus 1 is? Is it still an isosceles triangle?
Yes. Wow.
Whoa.
Whoa.
That's all it is. Let's try another one.
I
We're
am
running out of much time.
stupid.
Oh, we didn't. No, don't beat yourself up.
It was only the first one.
Wow. That makes it even worse.
Is this for homework?
Yeah. The only one that's on here, because I want you guys to get through as much of this as possible, because this is what we're going to be doing the course of for
All of this?
to get through as much of it as we can for tonight through to tomorrow. We'll check answers again tomorrow. But the only one on here I want you guys to skip is the very last proof. The very last proof deals with isosceles triangles, and I'm not going to make you guys do a proof with isosceles. Okay? So don't worry about that one. We probably could have, but yeah, whatever the last number is. So you just don't worry about that back page. It's on the back page. So you don't have to do it. Again, we get to this problem here. What type of triangles do we have?
A bow tie.
We have bow tie. We have isosceles, and you're already yelling bow tie, which means if this is 2x, what's this? 2x. Good.
It's so small.
Now, if this is 6x plus 6 here at T, what is it at D? How many degrees are in a triangle, ladies and gentlemen? 180. So what do I have to do to solve for x? You add all three of these together. 6x plus 6 plus 2x plus 6x plus 6 is 180. That's how you work through to solve for these problems. You saw a bow tie right away, which meant you had a vertical angle. You had an isosceles triangle because you had your tick marks for here, which meant that they have to look at the base angles, which gives you your base angles. So 6 plus 6 plus 2 is 14. And now you're at a very, very easy two-step equation. Yeah, subtract the 12. And divide up by 14, and it's 12, isn't it? There you go. That's it. That's it, guys. Seriously. Now, if I were you, I would try and get done all of my algebra tomorrow, or for tonight. All the algebra problems are on here. There's only like 8 or 9 of them, okay? Because we'll start with that tomorrow, and then we'll segue back into the proof. That way proof stays fresh in your minds, okay? You want to try and go through the proof, go for it. Also, if you hadn't finished, yes, you probably noticed that the last 6 proofs were the same ones we did in class the day before. I just changed the pictures.
On the homework, there's like the same one from the worksheet we got too.
That was the whole point. I wanted to see if you got it and then realized, wait, I should check my work. Good. There was one that the letters were backwards, but I'm sure you hopefully figured that out. So there's what, 5 of these that are on here. If we didn't get, we did 2 of them already. So otherwise, we've got a couple more to check on here. So you guys have, you basically have every single proof that we have, except for a couple that I didn't show you yet. But all the algebra, everything is in front of you now. There's nothing new that I can show you over the next 48 hours. Okay? Seriously. It's all there. Okay? Work on the algebra ones for tonight. We'll do proof stuff in class tomorrow, and we'll be ready to get out of the stuff for Friday. Okay? Great.